Yeah, we're going to be looking at events. And I briefly discussed about events in our previous class, which we said something about replacing asynchronous programming with event emitters and all of that. We briefly discussed about how we can trigger events by sending a message to signal that an action was completed, and how JavaScript developers can write code that listen to events from an event emitter, then allowing those events to like execute functions every time those events are triggered. And I think I talked about how strings are composed of an identifying string and any other data that need to be passed to the listeners. So typically in this class, we explore events in depth. And first of all, we learn how to emit events. Next, learn how to listen to events, capture event data, handling errors, managing event listeners. And if we still have time, we will discuss on how to plan our upcoming project. It's a mini project, but then I want us to get familiar with how things work. We set the project up from scratch together. We document it together. We create the GitHub repo together, and then we create issues together, then see how we can resolve those issues by creating branches, creating pull requests, and then reviewing those pull requests together. Then we see how things work, how in a typical working environment where different developers work together, we see how they contribute. And we don't have tools like Kanban boards or like agile methodology, like following agile methodologies. We don't have such tools, but then we can see how we can try to maneuver that. We can see how we can try to like make things easy for ourselves, and then we get ourselves used to working with other developers. We see how that works. Okay, that's if we still have time, but if we don't have time for today, then we'll look at that in our next class. So, emitting events. There are two, let me say two ways, or is it two common ways to create an event emitter in NodeJs. And the first is to like use an event emitter directly, the event emitter object directly. And the other method is to like create an object that extends the event emitter object. You know, objects can inherit methods and properties from other objects. So, but choosing a method to use depends on your use case, depends on what you want to do and the problem you want to solve. So we try to look at these two methods, but then in this class, we focus on inheriting from extending the event emitter object. As we inherit its properties and object, then we try to reuse them in the project you want to build. Typically, we're building a simple project that will help us understand event emitters. And this project I have in mind. it's typically a ticket manager where if someone buys a ticket, you will send them an email, not actually a real email, but we just implement that feature. Then you save their data to the database. Without speaking much English, let's jump into writing code and see how we can emit events via the event emitter class. And this class is part of the event module. Let's see how it's part of the event module, and it's a NodeJs built-in module as well. So let's jump into trying to see how this works. Require events. Yeah, I think this is the event emitter class, event emitter object. So in this case, you create an instance of the object and you see const let's say event is equal to new event emitter, something like this. And then you say event dot emit, event emit my event of anything at all. But then when you run this script, you will see nothing on your console because we're actually not logging anything on the console. But then the emit function is used to fire events. So we need to pass the name of the event to it as a string. And after that, we can add any number of arguments after the event name. Events with just a name are fairly, they're actually limited. You can use them for various experiments, but they are limited. The other arguments allow us to send data to our listeners. You may have a listener that after the event complete, you want to send the data to that listener so that the listener can perform some kind of processing also. So when we set up our ticket manager, our event pass data about the purchase of the tickets when it happens, like because event listeners we identify it by the name. So for now, we've seen how we can use in our previous class when we discussed the inbuilt modules, we talked about events and we see how we can emit events and then do little things with events, but we didn't go in depth. So now we have to see how we can move to seeing a more complete example of publishing and listening to, and then acting upon events. So by doing this, we will not be using the event emitter object directly. We will inherit from it. Inheritance here, we just extend the event emitter object to match what we want to really implement. Okay. So now let's create another file and let's just call it let's just call it tickets.js, and then we import the event emitter class, the event emitter object, I mean, and then we extend it. Let's say ticket or ticket manager extend event emitter. And when discussing, when we treated ES6, we briefly discussed about the object, declaring object with the class keyword. The class, the ticket manager here extends the event emitter class. The ticket manager class inherits the method and properties of the event emitter class. So the event emitter class has the method of emit. So when it inherits all those from the event emitter class, it will get access to that emit method and other method that the event emitter object has. So in order to get access to those methods and properties, what we do is we call the constructor. And then when we call this ticket manager class, we want to pass in a number of tickets that we want to sell. Let's say we want to sell 10 tickets, 20 tickets, 30 tickets. We want to pass in a number of tickets. So we'll just say tickets. And then we'll call the super. So basically, what the super function is in is to access the methods and properties of the event emitter. The super function here calls the constructor of the parent function, which in this case is the event emitter. Let me repeat myself again. This super function here, it calls the constructor of the parent function, which in this case is the event emitter. So we are calling the constructor of this event emitter to get access to the event emitter's properties and then methods. So we will then initialize our ticket. They'll say ticket is equal, this or ticket is equal to ticket. So basically, this is our ticket manager class. And now we want to add a method to this class, which is the buy method. Now we want to call this method whenever a user or a ticket is being purchased. So we want to implement this method in such a way that when someone purchases a ticket, when we have like 5 tickets and someone purchases a ticket, the ticket's number will decrease by 1. If we have 5 and a customer purchases 1, it will decrease by 1 and the ticket will remain 4 in number. When another customer purchases another ticket, the ticket will decrease by 1 and it will remain 3 in number. So how do we go about this? First of all, we will implement this method. Okay, let's say buy. We want to get access to the person's email and the price person we use to purchase the ticket. We have the email and the price. So in here, once the person purchases the ticket, we want to decrease the number of tickets by 1. We want to decrease the number of tickets by 1. Then we want to emit an event. And the event name is buy. And then we want to pass in the email, the price, and then basically the time and the timestamp. Returns the number of milliseconds elapsed since midnight January 1970 this now. Okay. We want to pass in the time the person purchased the ticket. Okay, so now we've implemented our buy function. So we will now export it so we can use it in our index file. Basically, you can use any method. Module.export is equal to ticket manager. We're exporting it directly. And then we'll come in here. You see const ticket manager is equal to require of file tickets. Okay, now we've imported our ticket manager. I want to use it. Now we're done with emitting events. We basically use the object directly to emit events, but I only use that as an example. So as we're listening for events and capturing event data, you learn more about how events are being emitted. So basically what we have here, we've imported our ticket manager, and then we want to make use of it. We want to listen for events. So on listening for events, you call the event, you create an instance on this ticket manager, and then you call the event. Let's say you have the event emitter. Then if you want to listen to it, say on. Say on. Then the event name. The event name is string, as you can see on event is the string. Then after that, you pass in a callback function. This event name, then a callback function. A callback function that will return an action. But we do some kind of gibberish in here. But this is basically how to listen for events. So in this case, we've imported our ticket manager. And what we want to do is we want to create an instance on this ticket manager. See, const. Okay, ticket manager is equal to new ticket manager, and it's expecting a number of tickets. And let's just pass in 5. We want to say 5 tickets. Okay. Now we want to listen on the buy. Look at what we implemented. We have this event here, the buy event. So we want to listen to this event. When this event is emitted, we want to capture it. So what we're basically going to do is we say ticket manager dot on, then the event name. Which event do you want to listen? We want to listen to the buy event. Then we'll pass in a callback function. This callback function is basically an anonymous function. If you don't want to use arrow functions, you can do something like function like this without a name. This is also an anonymous function, but I prefer arrow function. It makes your code cleaner. So when someone buys this here, we want to simply log to the console that tickets, but something like this. Okay, so let's run our index file and see. Oops, events not indexes. Okay. So, okay, we're actually listening to the events, but we have not triggered the events. Now let's call the method ticket manager dot buy. Now we want to pass in an email. And let's say the email is KodeCamp at gmail.com. And I want to say we're buying these tickets for $30. And then let's run our file again. As you can see here, we have ticket bot. When you run it again, we're buying a ticket, and anytime we buy a ticket, we emit an event, then we listen to that event. As you can see, this is awesome. And we can actually buy let's say you have code at Gmail, buying a ticket at $30, and we have another event here, camp@gmail.com. You're also buying a ticket at $30. And let's see what's happened here. Okay, so right now we have 3 events and we've listened to all of them. First one, buying a ticket. Second one, also bought a ticket. The third one also bought a ticket, and we've captured all these events. While listening to them, when this buys a ticket, we listen to it and we trigger this callback function. We listen to this one also, we trigger this callback function to perform some kind of operations and so. So listening to an event once, remember listening for events, that's what we're looking at right now. So at times you may want to listen to an event once. Let's see, ticket manager.once. Listen to buy, but then this should be triggered once. Then you say this will be triggered once, and then let's say after that one, 3 more people will buy tickets. Okay, you will try to run this file again. As you can see, we have ticket bought, ticket bought, ticket bought. Then this will be triggered once. We have ticket bought and ticket bought. We have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And this triggered only once. Okay. Okay. So now we have seen how and if you try to run this again and again, no, Twitter. You see it's only triggered once. Okay, let me reduce the number of tickets here. Reduce here as well. And then run this. We have ticket bought, and this will be triggered once. We have 1, 2, and 3, but we only triggered it once. That's we want to listen to this event only once. So if you want to listen to an event once, that's how you do it basically. So now we've seen how we can listen to events and then listen to an event once. And then next, we're going to be looking at how we can capture event data. Capturing event data. So in this case, we create 2 different classes, one for our email service and then one for basically our so-called database that we will not be implementing. Okay, so now we'll go for a database. We have 2 files, email and database. Okay. Then we first of all implement our email class email, or should we say an email service or email, just an email. And then, yeah, say go ahead.
Okay, thank you, sir. I want to clarify something on handler and listener. So, okay. According to the last page, ticket.js. So, what came to my mind is that the buy method or function is the handler. where you emit is the listener. Is that
Yes.
right?
Yes, yes. The network is not that good. It's like it's fluctuating. Yeah, go ahead. I can hear you, but maybe.
Hello, can you hear me now?
Yeah, I can hear you now.
Okay, so I said what I want to confirm is the difference between the Angela and the listener. But according to my current understanding, what I understand is that the buy method here on line 9 is the Angela, while where you emit is the listener.
Yes, 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 yes. Basically, you can call it that basically. But here you can write any function to emit an event. Here you can call this an event emitter here. Then you can call this an event listener. Do you understand?
Okay.
Yes, event emitter, event listener. But don't also forget that this is basically an object.
Okay.
The network is very bad. I can't hear you. Are you clear? Are you okay now?
Can you hear me now?
Yes, but
Yes. Thank
there's
you.
noise in the background. Okay. So that's just that. Here, this is basically a function. And this type of function was, as I earlier said, it was introduced in year 6. This is a function. And this function takes in an email and a price parameter. And then when it's a buy function, when someone purchases a ticket, we decrease the ticket by 1. Remember that this simply means ticket. Okay, this dot ticket is equal to this dot ticket minus 1. This is what this ticket minus basically means. This is the meaning of this. So we just want to make it short, and we just don't want to repeat ourselves. We'll do something like this. Then after that, we emit an event with the purchaser's email, the price the person used to purchase the ticket, and the time the person purchased the ticket. So this is one thing with object-oriented programming. The paradigm we're following is actually basically an object-oriented paradigm where we just create different objects and then we bring them together to do what we want to do, and we inherit from other objects rather than rewriting everything from scratch. That's what makes object-oriented programming fun. Okay, so here we have our email, and this email service, we basically take a send function. This is where we want to send an email to the purchaser that you've purchased the tickets at this time, your amount, and all of that. So we take in the email as a parameter, the email of the purchaser, and then we log something like okay, email sent to let's say the person's email, so that we know that yes, we've sent the email. Then we basically export it. Module.export is equal to email, and then we come down here, and then we say const email is equal to what am I doing? Equal to require email. Then we implement our database object that will handle saving the users data in the database of class database. Then we have a method of save that will save the user's data in the database. We take the user's email, the price, and the timestamp. Let's just make it date or timestamp. And then we basically do something like consider log, log saving, users data saved successfully. Okay, to the database, something like this. Okay. And then we'll see. Okay. Let's just log the email. A price and timestamp. So we're saving it to the database basically. Then we'll do something like this so that it can be clear to us. Okay, so when someone purchases a ticket, we want to send them an email and then we want to save their data to the database. So here we will module export is equal to database. And then we'll come here, see const database is equal to require database. Okay, so now we have our database objects and our email service object that we want to use in our application. So here we instantiate, but all of them, we'll see const database is equal to new database. Okay, const email is equal to new email. It's our email service. Yes, and we've done that. So come down here and we'll do something like, we want to listen to this buy event as we were doing initially, but this time around, when someone purchases a ticket, we listen to this buy event, then we capture the event data. And this callback, we will listen to this event. This callback receives an email, price, and timestamp. Let's take a look at our tickets. Can you see the buy function? It's basically email price that is coming from the purchaser. Then you emit the buy event with the email, the price, and the date. And in here, we are capturing the date as a timestamp. Okay, so when we receive all this, what do we want to actually do with it? Then we call our email. We want to first of all send an email to the user. Email. Oh, what's happening? Okay. So email service. The names are colliding. Email service. I want to call our email service. And then we want to call this, is it the send? The send method, yes. I want to send an email to the purchaser's email. As you can see, our email service is taking a parameter of email, which is the purchaser's email. Then we log to the console email sent to the email of the purchaser. And then after sending an email to the purchaser, I will do Sorry. Please, can you all hear me? Because I can see someone asking, can anybody hear him?
You are audible. You are audible.
Okay, okay. Thanks. So we purchase a ticket and then we log to our console ticket bot. And the next thing, we send an email to the purchaser. And the next thing, we save the purchaser's data to the database. It's a database that save. And this, we're taking the purchaser's email, and we're taking the price, and then the timestamp. And this is basically it. And here, we want to purchase a ticket. Let's say KodeCamp is the email. I want to purchase a ticket with $30. So let's see what happens here. Okay. Yeah. Okay. So we have ticket bots, email sent to KodeCamp@gmail.com. Users data saved successfully to the database, KodeCamp@gmail.com. The price is $30, and this timestamp is in milliseconds. Millisecond, this is about a billion or trillion or so whatsoever. But when fetching this data, when you want to process it, you can actually convert this to an actual time and date by using packages like date FNS or inbuilt date time or something like that. Anyhow you want to do it.
Moment.js.
Well, this is basic. Yes, Moment. Yeah, Moment. Yeah, Moment is a good package for this also. Good. So this is basically how to capture event data. And you can see how this looks simple. With object-oriented programming, we implemented this separately. You can even come here and see email sent to email sent and delivered. You can do something like this, delivered to email, and then you come here and then you run this email sent and delivered. You don't need to go anywhere. You just, if you want to change anything in this object, you come here and you simply change it. If you want to change anything here, you come here and you simply change it. You can even add more methods here. You can do something like advertise. You can do something like advertise, which we take in lists of emails. Let's see, we have basically, let's just say an email, because you may implement an email service that when someone purchases a ticket, you want to save the email to your email service that you message you like use their email addresses, your subsequent ad services, like notify them of a new, like a promo or a new sale that you want them to benefit from or something like that. You basically take their email, and in this case, you may take an array of emails, or anyhow your email service works. You take their email, and then you see what you do here is you just emit an event. This dot emit advertise. Am I spelling correctly? Yes. And then you pass in the email to the callback function that you use to listen to this event. Then you come down here and you do something like, oops, let me just take this down. You want to listen to the advertised event. Then you say tickets manager on advertise. Then you want to take a callback function, which is the listener, and you're listening to the event. And then you take your email that you passed in as a parameter to the callback function, and then you receive it here as an argument. Then what do you want this callback function to do? you want to basically log promo notification adverts notification sent to customer successfully, something like this. Sent to email. Let's say we want to just say send to this email we're taking. Yes, successfully. Then we want to actually emit that event. Then we say ticket manager dot advertise. Then what we're taking is let's say we're taking camp at gmail.com, something like this. And then we run our file. Then we see advert notification sent to camp.gmail.com successfully. So this is basically how this works. You can see how we can capture event data and then listen to events, trigger events. That is emit events. By triggering events, I mean emitting events. You can emit events, listen to events, then capture event data and all of that. Okay. So next on our list, we have handling error events. Okay. So right now we are not having any errors, but then what if we add a functionality here that in our ticket here, in our ticket object, in our ticket class, let's call it a class anyways, that will actually implement something like in the buy function, we'll do something like we'll add an if statement, a conditional statement there. If a ticket, this ticket is greater than, okay, let's say if it's exactly equal to 1, we want to say we want to log oh, let's just focus on the events and not this. Okay, let's say if it's greater than 0, we want to simply sell them. This is then we return nothing here, so that the function will simply return nothing. Then, but if we don't have any tickets, then we want to emit an error. And emitting errors, you do something like emit error. Then you take you anyhow you want it, but this one is a new error object. We're just calling it, it's an environmental kind of something. So we're just calling it directly, creating an instance, then we pass it in. Sorry, we are out of tickets. Something like this. So if we have tickets, when the tickets are greater than 0, that means we have tickets. We have 1, 2, 3, we have tickets and we want to sell them. So if they're greater than 0, the number of tickets are greater than 0, we want to subtract 1 from the tickets, then we sell the ticket, we emit the buy event. But if not, we want to simply emit an error. Okay, so let's just come back here in our index file, and then we pass in the number of tickets we want to buy. Let's say we want to buy, tickets we want to sell. So we want to sell 3 tickets. Then we'll come down here. First of all, let's comment out this advertise, and then remove this as well. Then we sell the first ticket. Second ticket will be bought by camp@gmail.com. How many tickets do we pass here? We pass in 3 tickets. Okay, the third ticket we purchased by code@gmail.com. and then the fourth ticket, KodeCamp@gmail.com. We also want to purchase a fourth ticket. So let's now see what happens. Let's run our file. And we're getting a kabli. This kabli is saying, okay, the first person bought a ticket, the third person bought a ticket, KodeCamp bought the first one, Camp bought the second one, the Code@gmail.com bought the third one. But then when KodeCamp wants to purchase another ticket, we have an error. The error is thrown unhandled error event. We have an unhandled error here, which is an event which we emitted by the event emitter. Then we have the error here. Sorry, we are out of tickets, but this is ugly. Can you see? This is actually an error we are not handling, and we say unhandled error. So how can we basically handle this error? How can we handle errors in our events? This looks ugly, and we want to handle it in a very nice way, so that if we don't have any tickets, we just notify the purchaser. No, or sorry, please, we don't have any tickets. So what we will do here is we'll come down here and say, if there are any errors. Okay, here we are listening to the buy event, and then basically we want to listen to the error event because we emitted an error event here. Can you see? We emitted an error event here. So now it's time to listen to it here. Sorry, error events. And notice the names. If you make any mistake, I'm putting like this. Let's do something like this and see what will happen. And then we take in a callback function that the error will be passed to as an argument. Then what we want to do is we want to notify the user that we are out of tickets. So, okay, we basically just log error to the console. But then if we run this, if we run our script, we're still getting an error. We're out of tickets because we made a mistake and the spelling here is not correct. We have to add R, the end, to handle errors in event emitters. So let's run our script again and see what happens. Unhandled error event. Is there anything I didn't see? Okay. I think I should move this up here. Okay. So I'm still getting this ugly error. Okay.
So I think it should be console.log error.message. Okay.
Let me do this again. Have one ticket by tickets tuned. Error. Let's see. Error. Let me see. Okay. Yeah. Plus, if you log this error. Okay. Well, log error. Type of error. Okay. The error is actually an object. So we want to bring out the message from the error. What we can see here is the type of error is actually an object, not just a string. So that was why we're getting a kabli. So we want to bring out the message from the error. Okay. Thanks anyways. So we now have our error handled. And we have, okay, let's just limit this to, instead of writing database. Okay, that's cool. And then we have the first user bought their ticket, a KodeCamp, the second user camp, and the third user code@gmail.com. Then the KodeCamp want to buy a ticket again. Then we just sent him a message, sorry, we're out of tickets. You have to wait for 25 days or so wait for 24 hours for new tickets or something like that. I don't know. Okay, let's say something like that. Okay. Sorry, we're out of tickets. Wait for 24 hours for new tickets. The user will say, oh, 24 hours. Let's start counting. And we've handled our error successfully. Can you see how sweet this is? Instead of doing things like that, whatsoever like that, we just handle our error and then everything looks nice. Okay, what else on the list? We have the managing event listeners. So how can we manage our events? Okay, let's say event emitters, they have some kind of mechanisms where you can monitor and control how many listeners are subscribed to an event. Okay, let's say this is a kind of a publisher and subscriber pattern in NodeJs. So we have this mechanism, we use it to control how many listeners are subscribed to an event. Okay, and there's a function to know how many listeners are connected or are subscribed to an event. We use the listener count method that includes that is included in almost every object. So the listener count method accepts one argument, the event name you want to count for, and then you get to see how many events. Okay, let's see how this basically works and how we can see how many subscribers that have subscribed to this buy events basically. So we'll come down here and we'll do something like okay, let's just say results is equal to ticket manager, and then we want to listener count. We have listener count here. Then we'll pass in by, and then we want to say log result. Okay, then let's clear our console and then expand it a little bit and then run our script. And then we have one. Is that true? One. Yes, tickets. We have only one subscriber here that's listening to this event, just one. Okay, and we can basically see, we can even make this more meaningful. We can say something like, and use template strings and we'll say, result. Oops, what's this? Okay, result for the buy event like this, so that we'll see one for the buy event, guys. Also like one subscriber for the buy event, and we can do something like this for the error event as well. And do result 2, and we pass in the error event, and then we log the same thing. And we have a result 2. One sub for the error error event. One sub for the buy events and one sub for the error event. Let's assume you have this and you want to use it globally in your application. You want to use it in different files. So basically, when you import this ticket manager in another file and you listen to the buy event, the listeners becomes two listeners, and so on. When you import it in another file and you listen to it, the listeners will increase. So maybe you wanna monitor the ticket manager class. You wanna know how many listeners are listening to it. You will just implement the logic, and then you will get the result you actually want to get. Now, this thing here, okay, let's say what you want to do here is a kind of complex something. You can actually abstract this function. You can do something like, you see, function or an arrow function. We're using an arrow function here, so let's make it arrow. Handle purchase, something like this. Handle purchase, which is an arrow function like this, which we take all this and then you paste it in here. If you understand the continuous passing style, the CPS, you know how this works because we already discussed about that, and we're not going to, sorry, this is equal to, we're not going to be going over that again. Then what you will do here is simply what is it? Cut this, and then you bring it here. Then you do away with this. Then you pass in handle purchase. And when you run your script, everything still works as expected. And the error const handle error, which is equal to, you take in an error as an argument, the error as an argument, then you log, no, what did we do here? Error.message, like so. And then you come down here, then you put in your handler, then you run your script, and it's still working as expected. So if you want to make your code cleaner, you write your functions separately, then you bring them in. And this is basically how to write code. It makes your code cleaner. If you want to change anything, you change it without touching this. You just come to your function and do whatsoever you want to do. Oh, sorry, what are we logging to the console? Sorry, we're out of ticket, wait for 24 hours. You can actually come here and say, oops, something like this. And then on a new line, we display this with template strings like this. Then let's run our file again. You can see, oops, sorry, we're out of tickets. Wait for 24 hours. Okay, and we're doing this. Let's bring it like this. We don't want it to. Oops, sorry, we're out of tickets. Wait for 24 hours for new tickets. And this is it. You can do whatsoever you want to do. And I believe we've learned much about event listeners, how we can listen to events, how we can emit events, how we can handle event data and handle errors and all of that. where we're managing event listeners, how we can manage our listeners. I know how many people are subscribed to our listener and all of that. So any questions concerning event listeners? Any questions? Yeah, Sonny, go ahead.
Okay, good day, sir.
Good day.
The error, the on error, that I
Yeah.
just want to ask, do you emit the event before listening for it, or it is already is built in NodeJs?
The error, if you check your this in here, we're actually we're emitting an error here. We want to specify how we want this error to be handled. So if you don't emit it, this will fail quietly and you get an error in your, it will fail quietly. Like let's say you want this ticket, if the length is greater than 0, then you actually want to sell your ticket. But if the length is not greater than 0, then what do you want to do? That's where the error comes in. You just want to emit an error so that then you can handle it. You understand? So that's why we emit an error here, then we come down here, then we listen to this error and then we handle it.
Okay.
Yes,
Okay,
but
sir.
the error here, this name error here, you can actually come here and then change this to error and then come to your index and then change this to error as well. The name matters, and then you run your function and it's still working as expected. Can you see that?
Okay,
Yeah.
no problem. I thought it was built in with NodeJs.
Not really. Okay. Any other questions? I guess no questions. So let's move on to the next thing on the list. Okay. I believe before I continue, please, who is that? Your mic, this background noise. I don't know whose mic is not me. Is this Sonny? Okay, good. For our tax manager project setup, this is where we start applying everything we've learned. And not only that, we're also going to learn about version controls and how we can manage, like we can manage a project. Let's assume you are working with different people across the globe, and then let's say your partner is in US and you are in Nigeria, another is in Canada or something like that, and you are working on the same project. So you have to contribute to that project. But how is that possible? That's where version control comes in. And the most popular one we know is the decentralized version. We have two types: the centralized version controls and the decentralized version controls. And then we have the Git, which is the decentralized version control, the most popular one, I think. And then if you want to set up, I'm not really teaching you Git because that is something you're supposed to be accustomed to because you are an intermediate, not a beginner. So I think you know more about Git. But then we're going to be introducing some more advanced things in Git, how we can create branches, check out branches, then create pull requests, review those pull requests, then merge them into our code bases. But then in this case, I am the only one during the classes. I'll be the only one working on the project. So I will then teach you how that is done. I will review the pull request by myself. And then I will teach you how to merge it. But I'll also teach you how, if you are you have multiple people working on the same project, how you can basically create a pull request and tag your teammates to actually review it for you, or your project, I mean your senior developer in your team or something like that. we'll basically look at those things. Okay. So without talking too much, we'll be setting up our project. We're not actually going to be building anything today, but we're just going to run the setup, and we're going to make the setup so standard. We're not going to use any external package. We're only going to be using only the Node inbuilt modules to actually build this project. And it's a task manager that supports CRUD operations like create, edit, delete, and what else? Create, edit, delete, and then list or fetch. You can actually list the tasks, and then you can view a single task by its ID. So with these implementations, we learn how CRUD operation works with Node and how basically Express is implemented under the hood, how it works. And everything is being handled for us in Express, because if you want to build an application with NodeJs without using Express, you have to rewrite everything from scratch, and then you know how difficult that is. You have to handle everything by yourself. And if you don't know, the Node.js learning curve it's wider than the solely Express learning curve. I started using Express when I had a little knowledge about Node.js. That's how fun Express is. I used it and even built a server that I built. Actually, I was eager to build a blog for myself. I built a server for my blog that can create posts, delete posts, and then fetch posts for my readers. But I actually took that down, and then I used GitHub APIs to actually save my posts on GitHub. And that is another topic for another day. And if you learn Node, like we've gone through Node and we've seen how emitters work, event works, and streams works and everything. So by the time we begin building simple applications, by the time we build this task manager without using any external package, you get to understand how everything works under the hood. And the assignment, the stage 2 task, if you make research and you get to build to complete the assignment, you also get to understand how some things work under the hood. Why I always mention behind the scene and under the hood is you can't just use things as a software engineer. You must know how those things work. You can't just use the console.log function if you don't know what it does. And believe me, many of us only know that the console.log, the console has, it's an object and it has different methods. Console.error, console.log, console.directory, and all of that. So we basically don't know all these things because we are focused on one thing. We just want to know, we just want to build servers, we just want to do this, we don't want to do. But you will find yourself in a team where maybe sometimes you have to take up everything all by yourself. You have to act as let's say the team lead, where you act as the DevOps engineer. You also act as the senior developer. You have to automate workflows. You have to set up projects, and the project structure is very, very important. As one of my mentors earlier said, Ken Dot, he said, the author of React Testing Library, he said, if you don't set up your React structure in a good way, you will suffer for it in the long run. The developers working on that project will suffer, and the users will suffer the most. And I came to realize that is very, very true. Because if you don't set up your project structure in a very good way, the developers will write code that is not friendly, and connecting those modules or code components together will be hard. And that is where you kind of bring different methods to do things that sometimes doesn't meet up expectations. So in that case, users will find it difficult to use your applications, and then they will find it difficult to like what the application is meant for. They'll find it difficult to like use it for those purposes. So your application structure, it's very, very important. And in Node.js, in Express.js, we build monolithic apps, and then we have microservices apps where every let's say every component or every functionality of your app is built separately and then integrated in your app. In the case where you have the blog section of your application, we have the authentication component. Let's just call it components. The blog component, the authentication component, and then you have actually the this you are managing the task component. So what you will do is you will implement the authentication service separately. Then you implement the task component separately. Then you bring it together. Then you know how to like connect them together so that even if the task service is down, the authentication will still be functioning, and then you don't have to go all over again and then change something from this that will break that. If one component is down, the other components are functioning. That's basically how microservices work. But in monolithic kind of approach, you build your application and we've been using that. That's mostly what other developers. And if your app is not large enough, you don't have to use microservices. You just build everything and then host it. But then what I want you to understand is project structure is very, very important. And what we're going to be doing is we're going to be planning our project. And first of all, we'll create a branch for that project in our directory. So in creating branches, if you want to create branches with Git, what you basically do is you say Git branch, and then the branch name. Let's say I want to say, and in giving branches name, you create issues. If you create issues, you write your name. Let's say my name is Christopher Sesu, and I want to do something like Christopher Sesu slash. Is it a WIP work in progress, or is it a hot fix? Is it a bug fix? Is it a feature? Let's say it's a feature slash what's a basically what I would do is I would do a dash, and then the feature the issue ID. Let's say we've created issue on GitHub, and this issue ID is basically number 2. Let's say 02, and then the name of the issue. Let's say add documentation. Okay, so I'll basically create this branch, and then I'm not going to create it. I just want to teach you how you can do this manually. And then if I want to check out, after creating this branch, it will be created. And if I want to check out, I will say git checkout, and then the branch name, that long thing you've seen there. So you have to keep note of it. So that's the reason why I don't like doing git branch and git checkout. So there's a short form for this. You simply say git checkout B, and then the branch name. So in this case, I wanted to create documentation. So what I want us to do here is git checkout branch. The branch name is my name in short, CS, and then I'll say docs, and then you say we have not created an issue on GitHub yet. So what we're going to do basically is we're going to say add documentation, something like this. And then it has created this branch, and it has also checked out. So switch to a new branch, CS/docs add documentation. So we are in a different branch right now. So what I want to do in this branch is I want to create a folder, which is okay, yeah, this is make directory. Then I want to give my folder name as task manager. And then if you want to do it once, you can say, and after creating the folder, then navigate, change directly to this folder, which is the task manager. See, and while changing the directory, you also want to do it once, and you also want to like create a file like the README file, and you say, and after changing directly to this folder, create this file. Then you touch, and this touch is Mac. It's Mac support the touch, but if it is Windows, you will do something like echo, then double fold arrow, then the name of the file, which is readme.md, and MD stands for Markdown. Okay, so now if you run this command, your task manager folder will be created. You change directly to the task manager folder, then you create your file. But let's do it manually so that you understand what's going on. Make directly. Okay, now let's see. Task manager. Nope. Okay, directly task manager. Okay, as you can see, we've seen our task manager here, but we're not currently in the directory. Now, if we try to list the content of our current directory, we see ls. That's basically list content. Look at the content. We have the folders here, the modules, and the task manager. We can even list it in a long format. This here, the dates, the permissions, the file, we have the user, we have the group and the author's permissions here. But that is out of the scope of this class. We're not going to talk about that. And then we have the link, the symbolic links, the symbolic links for all this, and then the author's name, which means that the staff, the group, and then the permission code, the date created, and the name of the files, and all of that. And we may have hidden files. If you want to list the hidden files as well, you can do something like this, which is, we have the git, which is hidden. Any file started with the dot, it's a hidden folder or a hidden file. So if you want to list both with the hidden ones, you then do something like all the hidden ones will be listed. We can do something like ls. We want to list the hidden ones and in the long format, you do something like this. Then you have all your dotted ones will be listed in the long format. This, as you can see, this everything is listed in the long format. And that is sweet. Then now we want to change directly to our task manager, cd task manager. And we're now, if we list the content of the task manager, we can see nothing is inside. Then we want to create a README file in our task manager. Then we see, I'm using Mac, but then most of us are using Windows. So let's use the window command, echo readme.md. Okay, now let's list the content of our folder. Then we can see that we have one file, which is readme.md. Okay. So we have readme.md in our project right now. So basically, what I want to do, why we need a readme here is, I want to write some documentation so that we'll be able to plan our project perfectly. I also want to teach us how to use GitHub commit messages, how we can write good commit messages and all of that. So now we have our file. So we'll open our file, and then I'm not going to, what I'll be writing, I'll be explaining to you, but it's only based on what I'll be writing, because Markdown is another thing on its own. If you want to learn Markdown, you can go learn Markdown, or you can only learn it for documentation purposes if you wish to. But if you want to learn it so you can work with it in your applications, that's fine. So this is heading 1. Then we do something like task manager. And then we try to give it a description of, this is a basic task manager that we manage users tasks. Let's just make it something like that. It will perform CRUD operations like create, is it create, edit, list, and delete. Yes. So basically, we've written we've seen how this works. And permit me, for once, what I'm going to be doing is I will have to commit this to GitHub, upload them. We'll see how this looks, and we'll see how everything I'm writing, how it will appear. So what we're going to be doing here is we want to add this so we can commit it to our remote repository. So we say git, if you want to commit, first thing you do is git add everything. If you don't want to add everything, if you want to add a file, you just write the file name. But I want to add everything we've worked on today on this very branch. Say add everything. Then we want to commit, git commit message. Then this is documentation. So you say docs. This you will see how this, if it's a feature, you do something like feature, then you write the message. But this is documentation, so you say docs. Then you say just in short, say add readme.md file, or just add readme.md, something like this. We just do like this, and we've committed our readme. So now Git is now tracking our readme. So we want to actually push it to our repository. So what we do here is we simply say git push. But I've not set up the stream where it will know where we are pushing our branch to. So if you say git push, look at what say git push setup stream origin to. So the current branch cs/docs documentation has no upstream branch. Yes, we know the branch is not GitHub is not tracking the branch. So to push the current branch and set the remote as upstream, use git push server tools. So what we do is we come here and then we copy this and then we paste it here. Sweet, and we push our this into our remote repository on GitHub. So basically, what you will do is you come here. Okay. Come. Sorry about that. Oops. What is this? Okay. Now we'll create. Open GitHub. Go here to our repositories. Then we have KodeCamp. We'll open the KodeCamp. And then can you see compare and pull? We have cs/docs and documentation had recent pushes 1 minute ago. Then if you click here, you have two branches, the main and my branch. This CS stands for Christopher Sesu / docs and documentation. The docs here is basically the let's say the feature, or what this stands for. The docs is for documentation, but what we have here is add documentation. If we have another thing like we've added documentation and we want to do something else, we'll write something else here. But here we have the main branch. The branch we are on now is the main branch. So if you come down here, if you check here, you will not see the task manager folder. There's no task manager folder here because we are on the main branch and we have not matched this to the main branch. So let's switch to the docs branch. Okay, so now we can see our task manager and look at the commit message here. Docs add readme file. So when you look at the commit message, it describes itself. When you committed this, what did you do that you committed this? We added a readme file, and this is sweet. And right here, I updated this 2 weeks ago. I updated a readme, so I added docs update readme. Okay, so let's go into our task manager folder. Okay, and our task manager folder, look at what you've got. We've got a task manager, which is the heading one. Then we have, this is a basic task manager that will manage users' tasks. It will perform code processes like create, edit, list, and delete. And you can see this appear as code because I was using backticks. That's if you want to write code, you use backticks. And if you want to write code like, you can do something like this. This is a code block, and you write something here. And you write something like function add a b. You say return a plus b. And this, if you commit this and see how it appears, it add everything, and it commit docs update readme, and then git push everything. Okay, so now if you come here and then we refresh, let's refresh and see what we've got. And can you see that? This is GitHub flavor, and GitHub supports Markdown, so you can write Markdown. You can, and if you specify this, you can even add something here like JS or JavaScript, and it automatically highlights. If you remove it and you add Python, it automatically highlights. But let's say we're dealing with JS, so add JS, and it automatically highlights. And if you push this, okay, let's do it once more. And then you come down here and then you refresh again. And you see that your code is highlighted because you specified the code, the language here is to be JavaScript. You can do something like C or Python or Kotlin or anything at all. And GitHub will recognize it. So that is basically how to write code blocks in Markdown. Okay, so now what do we want our project to look like? Let's assume we are working with different people, and then what we do is we create a table here. We create a table, and then inside this table we have something like we have, what are these basically called? These are functions. Let's say functions, and then these functions and their what? Let's say we have the functions and their, let's say, operations, something like that. Let's just leave it like this, and then you come down here, and then you do something like this. Then you say create, and this, what does the create do? You do something like this. This creates a new task. This creates a new task. And let's leave it like that. Something like this. And then you add another one like edit. This edits an existing task like this. And then we run this once again. We're still updating docs. And then you come here, and then you refresh. And you can see our task manager. You can see functions and operation. We have create a new task, edit an existing task. That is how to create a table in Markdown. So if you are working with different people in the team and you need to document anything, create, and then you write in depth how those things work. But here we're just basically learning how to do all these things, so we don't have to do that. And let's complete it, and then let's add the list. And then you see you need to add this list or a or task something like this. Then we'll remove this one as well. Then we add another one, which is delete. Okay, edit by ID. Then list. Then here we have delete a task by ID as well. Then we save it. Okay. Now we've created that. So now we are not installing any .env package. We're only, what you can do here is, you can see, if you want to use, let's create an index.js file here. And then let's come to our command line. Then we export an environmental variable. Export port is equal to 3000. Then you come here, you log process dot env dot port. Okay, node index.js, and you see 3000. This is basically how to create an environmental variable on with your terminal. You can create it on the terminal, or you can create a file. Basically, there are some environmental variables we don't want to push to GitHub. So if you have any, without using the .env file, you can basically, for development purposes, you can do it here. But in production, every hosting service has a place where you can save your environmental variables. So you don't need to do this there. All you need to do is go there, then save your environmental variables, then access them. Then you can see const. When creating our server, you can see const port is equal to process.env.port. And then you can see something like, or if there is no port, it's 3000. But this has no meaning to me, because if you want to hide your variable, then why still expose it? Then you come here, then you say log port. Then you run your script. I still have 3000. Then you can see something, you can do something like export session secret equal to KodeCamp node. Hit enter, clear your terminal, come down here, copy this, paste, and then get your session by saying session secret, and then you say your session secret is equal to process.env session secret. Then you console your port and your session secret. Then let's see what we've got. No. Okay. Yes, and we have got our session, and you can even do something like this, port, and then you can do session secret, so as to be clarified, so as we know what we're viewing. You have port 3000, session secret is KodeCamp. Can do like this. Sorry, like this. Port is 3000 and session secret is KodeCamp node. And that was exactly what we stored in our environmental variable. So that's basically how you can create an environmental variable. So right now, we're going to create, this is our index file, and we've seen how we can work with environmental variables, that is .env. But if you don't wish to do that, you can create a file like config.js. And inside this config.js, then you can create a new file here. dot git ignore. Then inside your git ignore, you say you should ignore the config.js file, so that when committing all your files and folders to GitHub will basically ignore this config file and it will not commit it, so that people viewing your project or other, basically you don't want your members to get access to these variables, or you just want them to use it blindly without knowing what these variables are, so that they cannot override it and then use it in another application without your notice. Then this GitHub will ignore this file, this .git ignore. It will basically ignore this file. Now you come to your config file, then you say export port. Okay, or you do something like const port is equal to 3000. Then you do something like const secret is equal to like KodeCamp. Then you export port, and then secret. Then you come down to your index file, then you import, you can see from config.js, you say import port and a secret. Then you log port and secret. But this won't work. Let's initialize a package.json file. npm initialize. Yes, we don't have to do this manually, just do it for us. And this is done. Where's our file? Why is it taking time to appear here? Okay, look at it down here. Look at the description. Look at what happened. Let me show it to you clearly. You have to take note of all these things. Look at the name, task manager. There's a folder name. The version is 1.0. The description, this is a basic task manager, because this is the description in our README file. It ignored the title and then took on the description. Can you see what is in here? Description. This is a basic task manager to manage users' tasks. It will perform CRUD operations like create, edit, list, and delete. The main file is the index.js file. That's create, test, error, no test specified, and exit one if you want to run test. Okay. If you do something like npm run test, can you see this? Error, no test specified, and exit error, no test specified. So this is basically this what this script, this command here is doing. So the license is IAC, the keywords. We can input some keywords here like KodeCamp, and then CodeHouse. Hey, I don't know how to spell. Is it code? Is it the Z? Okay, let's use a CodeHouse like this, and then we say NodeJS, and then we say Express. NodeJS. That's enough. Some keywords. We specify some keywords in a package of this. Then what we really want is we want to use modules, not CommonJS. Then we say type modules, not CommonJS. Okay, basically that's all we need for now. But you can specify a script. You can say something like you can say start. Then you can say node index.js. That's if you want to start your application, say node index.js. So if you come down here, let's go back to our index.js. Okay, we have it. They say npm run start. As you can see, let me expand this so we can see it. So we say task manager, the version is version 1, and then the start script. What is in the start script here? In the start script, we have node index.js, and then node index.js is starting it. Then we logged our port and then our secret. So can you notice this? If I type node index.js on the console, it will still do the same thing. But then we want to avoid that. We don't want to know what the file name is. We just want to run it. And then when we get to where we use NodeMon and what NodeMon does under the hood and all of the rest, we'll know how this works. But then this is basically what it's doing for us. It's actually running the command for us instead of us typing it on the on the terminal. It's running it for us. So that is sweet. So if you don't want to export your environmental variables on your terminal, you do it in your config file here. And that is nice. And then for today, we've created our index.js file, our package.json file, and then we've basically implemented the task manager, the version, and everything. And then there's one thing I did not introduce to you, and let me introduce it today. It's a way to import inbuilt modules in Node.js. There are different ways. You can do something like const is equal to await import fs. Then in fs, we have fs.read. We have read file sync, something like this. Then we can come down here and we say log fs, log read file sync. And then what are we taking in the file part, which is the read readme.md, something like this. So let's see let's see npm run start. Okay. Can you see? It's actually returning a buffer. Yes, because we didn't specify the kind of, I think we need a callback function. Yeah, something like that. And then to specify, you can see const. You can do something like this. Okay, like this. Const r, which is result, is equal to this. Then log result to string or to JSON. No, we don't want to log it to JSON. We want to log it to string. I can actually leave it like this, or you can specify the encoding you want. What do you want? Is it binary, hex? Okay, let's say binary and see what we have. Then log it, npm run start. Oops, can you see this? No, it's not returning any binary form. Okay, you can see, no. UTF-8. Let's just do what we are here for, UTF-8, and you still see your content. Or you can do something like await import node fs. And this is supported in version, I've forgotten the actual version that started supporting this, but then we'll talk about it in our next class. So if you log this to the console, we still have our README file contents on our console. Can you see that? And this is sweet. So basically, you can import, and you can even import, add another one like write file or write file sync or write EV or anything you want to talk. Okay, so that's it for this. You can actually remove this node and leave fs and it will still work. But note that you cannot use this without specifying the type, which is module here, because Node will assume you're using CommonJS and it will throw an error. Okay, so that's it for this one. Okay. So actually, what packages do we need? We need to create our server first. Then we need to have our database. Okay, so let's create, down here, task manager, we have a folder. in a large application, we have a folder that will configure our database and all of that. But in this case, our database is a JC file. So we just create a file. Let's create a file, a new file, database.json, like this. And then we have our tasks, which is basically an array of tasks. Okay, and then here we can export default. Oh, I get an error, export default, expect I just seen something like this. Or if we don't want to do this, basically our database won't be large enough. So we can just bring it in our index, and then we specify it at the after the import. We say import HTTP from node HTTP, like so. And then we'll specify our database cost. Database is equal to something like this, an object. Then we have tasks. Then we initialize it to an empty array. This is basically our database. And then we import util from node util. We're going to be using that as well, but then we're just preparing our project so that by in our next class, we just continue from where we stopped, and then we'll do something like const server is equal to http dot create server. Then leave this, create this function you're supposed to pass in here. Say function server handler. Then pass in a request and a response argument. Then we leave it empty. Then we come in here, then we pass in server handler. Let's learn how to abstract things. Then we'll come down here, we see our config file. We will import port from config.js. Then you come down here and you see server.listen. The server is expecting a port, a host name. Hosting is optional, the port is optional, and then a callback function, which is also optional. Okay, so we pass in our port, then we pass in our callback function. What is this? Sorry, pass in our callback function like this, and then we simply log to the console. Server up and running on port. Then we specify our port. Okay, so now let's run our application again and see what we've got. npm run start. Can you see this? Our server is up and running. Server up and running on port 3000. And let's chip in a little bit. Now, if I make any changes to this file, this server will not take effect. I'll have to stop the server and restart it again. And that's the reason why in production, in development with Express.js, we make use of NodeMon, so that NodeMon will watch for changes in our index file, and all the files used in our index file. If any change takes place, NodeMon will automatically restart our server for us. Okay, and basically, in our task manager, I forgot to, we have a folder, which is the source folder. And inside this, our source folder, let me stop our server. You just press Ctrl+C and your server will stop. Then you clear your terminal. And then if you want to use your command line to move files, you can do something like, okay, you want to move everything in the current directory, or you want to move something that starts with config. In our current directory, you want to move something that starts with config to source. Can you see that? Let's open our source, and there's config inside. What I'm actually doing here is I'm moving this file. I can actually specify only C, and actually that I want anything that starts with C, I want it to be moved in the source folder. Okay. Now you can actually, let me move this back to our task manager. You have to learn how to use command line. It's very, very we'll move it back. And then this time around, we want to move everything that ends with JS to the source folder. Okay, as you can see, everything is moved in here. We don't have anything out here. So basically, at first, all these things will be difficult for you to understand, but then there's an advantage of being a software engineer. You have to learn everything you come across. Just learn everything. Like me, I've learned a lot of things, and I'm actually a software engineer. I'm a DevOps engineer. I'm a database, what should I say? This is a database engineer. I architect databases and then I optimize them as well. And I work with databases, SQL, NoSQL, and all of that. A full stack engineer, so it took me time, but then I had to learn all these things. So if you want to be good at what you do, you have to understand. So this main here, we didn't talk about all this, the keywords, the author, and the author, let's say KodeCamp. Then the license, IC. If you want to know about the IC license, you can actually browse about it and read about the IC. Or if you wanted to change it to MIT or any other license, these are the scripts. And this script here, you can run them using the npm. You can run npm run test, and it will error, echo error, no test specified, and exit one, the error, no test specified. And basically, this is what the script is doing. If you run it, it will echo this. Okay, that's great. It will echo error, no test specified, and then it will exit one. So it's error, it's display the error on the screen, error, no test specified. The program exited with a status code of 1. That is error code. 0 means success, and then 1 means this is an error. So we have to exit this program with error code of 1. Then returning the control to the system kernel, telling it that, to the operating system, telling that, this program is an error, and we exited with the code of 1. So the operating system will know that this an error occurred and the program exited. Okay, just by the way, if you don't understand, you can make research on how these things work. Then the main.js is actually the entry point for application, which is the index.js. You can specify this as any other one. Then you can do this main src/index.js because we've moved it into the source. So when you say the main is the source/index.js, it's now in the source. This is the source of our application. So anything we want to do will be inside there, but the package.js will be in the root directory of application. The git ignore will be in the root directory, and then we have this here. So that is the type we're using, the module system, and the common JS, and our application is version 1. And the name of our application is Task Manager. The description is this. And that is basically how the JSON file works. And we have other things. When we start working with Express, you understand them more. But right now, maybe in our next class, we explain other things about the package.json. But for now, this is basically our application structure. In our next class, we complete our application structure. Then we explain what we want to do with the util module, the HTTP module, and other things, where we abstracted the server handler from the create server function, the create server method on the HTTP object, where we abstracted this, and then we passed in to write cleaner code. Then we listen to our server on this port, which is port 3000, and then we log. When the server starts, we log this to the console to notify ourselves that yes, our server is up and running. Okay, so right now, let's say git add. We want to add everything, and then we want to commit with a message of is it a feature? Yes. Let's say feature, and then you say project structure set up, something like that. And then we say git push, we push it to our upstream, to our remote repository. And then we come back here, and then we refresh our remote repo. Can you see this? Here is our documentation, our readme.md file. Here is our git ignore file, and here is our source. We can actually open our source. Then we see our index.js file. Then we see our code, and that is it. So that is it. And then we've seen how we can set up with Task Manager project setup. We've done this. We'll try to set up the basic structure for our project, and then by next week on Tuesday, which our next class will be holding, we'll be able to process and then do everything. We'll follow everything step by step so that you understand in depth how everything works. So that when you encounter something when building complex project, you don't have to, oh, how does this work? I never knew about this. We'll follow it gently, and then we'll understand how everything works. So, any questions? You can see it's only say that it's on the call right now. Say any questions? Okay, if no questions, then we actually call it a day, and then we meet in our next class. Thank you all.